Okay, so my field of research is digital linguistics. It's not really an established discipline. You can more think about it as a combination of linguistics and digital humanities methods and machine learning. And a major part, at least for now, about my research is internet and the language used online. And that's also what I'll be focusing on today. So, as we all know, the internet is a constantly growing source of information that has already brought quite a lot of changes and possibilities to our lives, both as individuals and as researchers. So, for instance, the internet has changed how we search for information, how we communicate, how we exchange opinions. All this is different than what it used to be. For instance, if you think about traditional encyclopedias that we used to have as books, they were giant, or phone books, or even just paper newspapers. They are not used the same way as they used to be before the internet. Now, many of the things we do online leave traces, and some of these traces are in the form of language. And together these linguistic traces can be used for data. It becomes quite giant, confusing, and there's a lot of it, but it also does enable quite a lot of new kind of research. Now, we all know that the internet is huge, and in terms of data, it covers billions and billions of words that are actually quite easily and quickly available if you want to. And thanks to these billions of words, the quality of many computer systems that analyze language automatically has improved quite a lot. If you think about machine translation, speech processing, information retrieval, their quality today is way better than it used to be, say, a decade ago. From a less technical perspective, the internet does allow us to explore people's beliefs, cultural changes, the spreading of information, disinformation, on a scale that's massively larger than what it used to be before the internet. And also, if you think, for instance, about rare expressions, you can't really study them if you don't have lots and lots of data. But now with the internet, you can do that. But of course, that's only one side of the story. So, because the internet's extreme size and diversity also complicates its use as research data. For instance, and also our everyday use of the internet. For instance, if you do a simple Google search, it can retrieve you thousands of documents. And you don't actually even necessarily get to know anything more about those documents. You just get a huge list of documents. And this is actually something that complicates the use of the internet every day. One way of using online data for research is to try to collect as much of it together into a database. Now, in our research group, we have developed these giant language collections that we call parsebanks by crawling the internet and then taking as much of the language as possible together into a database. So we have the Finnish Internet Parsebank, currently consists of about 8 billion words, 10 million documents of Finnish. You can imagine that just searching from this kind of database is not that simple. And moreover, the problem is that we are in linguistics and in the humanities. Usually just numbers is not enough for us. We want to ask why. And to get this why, the searching is not enough. We will need to explain the numbers, go beyond them. So even if just the searching is kind of complicated, it's still not enough. We need more methods. We need to improve the methods so we can actually get beyond the numbers and know what's happening there. So there's work to be done. Now, in order to get beyond the numbers, to actually be able to explain the numbers, one key question with online data is the same that we have with any kind of data we are using. What does it represent? What is the internet representative of? Now, that's a good question, because language actually varies extremely across different kinds of texts. For instance, here we have fiction from Jane Austen, Pride and Prejudice. Then we have a Wikipedia article, a beginning of a cookie recipe, and a writing exercise that my 7-year-old son wrote when we were living in Arizona. They are all valid texts, but they are at the same time different because they aim at doing different things. The fiction tells a story, the encyclopedia article tries to inform us, the recipe gives instructions, and I think my son tries to tell what he wants to do on spring break. So I will see Grand Canyon. And because of these different objectives and the situations where the texts have been written, they are actually quite different. We interpret them differently, but also if you look at the words and the constructions, they are quite different from each other. So now the challenge is that if we want to study language by just taking any language, by just adding all these together, by just lumping them all together, there's only so much you can do with those, because it's kind of like a bad average on something that you cannot actually measure. So because of this, one of the first things that we need to do with online data is to examine the kinds of text varieties that there are online. We know we have this and something else, but what all do we actually have? We are currently doing this for Finnish, and my collaborators in Arizona have already done it for English. So they took a large random sample from the English-speaking web, say about 50,000 documents, and they manually added information on the origins of the texts and of the text varieties to these documents. And one important finding they got was that actually online texts cannot be classified the same way as we would do normally in the printed world, because usually we would classify the texts to different classes according to the objective of the text, so why they are written. And that would be why, for instance, all these texts would be in different classes, because they aim at doing different things. But turns out that with online texts, it's not that the objectives are not as clear-cut as they used to be. For instance, here we have an example of the Finnish internet. It's been translated to English. The text is from the website of a wine brand, Jean-Paul Chenet. It's a Finnish site though. The text actually tells a story about the beginning of the company and how the company was founded. So it all started in the beginning of the 80s when a young French wine merchant had a dream. And as such, maybe we could think that the text actually is a story about something that happened in the history. But then when you think about the context and about the situation where the text has been written, it's actually on the website of the wine company. And they don't want to just tell the story, they actually want you to buy their wine. So that actually makes the situation more complex. And this is something that you have to take into account when you do want to classify texts according to their characteristics. So we are working on this by examining a large selection of documents from the Finnish internet and trying to classify them according to the model developed in Arizona when they were doing their experiment. Now with such a classification model and a set of documents, example documents, where we have manually identified the origin of the documents, we could develop a machine learning system that could learn to classify texts automatically to these classes. So in other words, we could detect automatically news, opinions, texts that want to sell something, etc. Anything we have here, we could also, at least to some extent, identify there. And with such a system, we could do two things. So first, what we could do is that we could analyze better and more the different kinds of text varieties we have online. And second, we could divide the existing web language resources to subcorpora so that they would have different sections for different text varieties. So that, for instance, our Finnish Internet Passbank would have sections for news, blogs, opinions, social media, etc. Perhaps we can even imagine a Google that could attach this kind of information to the search results so that it wouldn't need to be only documents from unknown origins, but we would somehow know that these are news, these include opinions, etc. Now, obviously, it's not this simple. So, first of all, we don't quite know yet to what extent such a system could work. We can imagine, we have high hopes, and I think we know that it works to some extent. But for instance, for the texts with mixed objectives, like the wine example, it's not clear if the mixed objectives actually leave linguistic traces. And if there are no linguistic traces, then I wonder how it would be possible to actually identify the mixed objectives. So that's one first challenge. Then another one could be that actually there's a lot of languages in the internet, and this needs to be done separately for each language because there are the manually identified example documents here. Now, and we are lazy and we would like to have a system that could detect these text varieties for different languages without all this manual work. So we would need to have some sort of other method for this. One option could be to use clustering, which is an unsupervised machine learning method, where we don't need any manually identified examples. So in clustering is commonly used in data analysis to find groupings in previously unknown data. And so because of this, we wouldn't need any manual work if this worked. We would just get somehow, in a data-driven manner, groupings where, for instance, hopefully those ones there could be, say, sports news. I hope they are. And in fact, this kind of text clustering has been done already in the 80s, and it does work quite nicely. The problem just is that linguistic data is quite sparse, or very sparse, which means that in a data set we have a lot of different words, but a large proportion of the different words actually only occur in a small number of documents, which means that our data looks kind of like this. So here you can imagine that the rows would be the text, the units we are interested in. We could have, say, at least some tens of thousands of them. Then the columns would be the variables, so say unique words in the data. So you would have other constructions. You could have at least 500,000 of those, maybe millions if you want. And there would be lots of zeros because many of the words only occur in a small number of documents. Now, you can imagine that any kind of analysis or clustering of this kind of zeros becomes complicated. And in fact, so we would need some way of reducing the dimensionality, which means just to make the rows shorter. The traditional way and how it was done in the 80s was to use this statistical method called factor analysis. And it worked quite nicely, but the only challenge is that it has to be done separately for each language too. And it was exactly these language-specific pre-processing steps that we actually want to get rid of. So this doesn't solve our issue. Therefore, we have been trying to find some other ways that we could use to somehow shorten the rows, and where we wouldn't need to still do any manual work. And actually, there are machine learning methods that can be done to do this, and it works for individual words. It works quite nicely, and the method is called word-to-vec. It's founded by or quite well described by the famous quote by J.R. Firth, saying that you shall know a word by the company it keeps, meaning that similar words occur in similar contexts. For instance, I don't think you know what a wampimuk is, but if I say to you that we found a cute hairy wampimuk sleeping behind a tree, you will get an idea of what that actually is. And that's because the context actually gives you hints about the meaning and also defines the meaning instead of just the word. And because of this, similar words occur in similar contexts. And because of this, you can actually, based on the context, also define word meanings. And what word-to-vec actually does is that based on the usage context, it tries to predict the most probable word. And while doing this, the method also predicts dense short vectors. So you can think about vectors. If you don't know what it is, you can think about just the rows I had in the matrix. Rows with a bunch of numbers, that's a good vector. And so word2vec gives those to the two individual words based on the usage context. And because similar words occur in similar contexts, similar words also get similar vectors. Oh, so kind of like this. So here you can imagine, you can see that cat and dog have quite similar nearby vectors because they are kind of similar. Then run and walk get similar vectors, etc. Now our idea is to do the same thing for documents, so that basically we could predict these short vectors, short rows for documents. And because if we could do the prediction like this, it would not need any manual work, and we could use those rows as basis for our clustering, and we wouldn't have to do any manual work, and that would be awesome. And so we don't have any final clustering results yet based on these vectors, but we have document vectors now that are trained kind of like these are trained for words. So we try to predict similar vectors, similar documents based on their contents. And at least the documents look quite neat. So here's an example text. It's about football or soccer, about the Premier League in UK, about player contracts, new Everton signing Nikita Jelavic, Fierce Rangers and Celtic will become second-class clubs, 6 million move, financially, so financial issues, administration, Premier League football clubs. And now if we look at documents that have vectors nearby this document, we get this. So it's also about the Premier League. And it's also about financial issues, cost controls, financial fair play regulations. So, and this just all comes automatically from the system where we wanted to have those shorter rows, those shorter vectors. And it seems that it actually works, at least to some extent. It does capture the document's semantic meaning. So this is quite promising, and I hope we will be able to have some nice clustering results on this. So I think, and this will also give something new for the analysis of this text, and something new to add to the studies that have been made in quite a similar framework already in the 80s. So I think it's kind of like a nice, on a more general level, it's kind of nice example of how machine learning can contribute to linguistics and digital humanities in general, give new perspectives on possibilities to how we can study language. So this is my second last slide. I've talked to you about the advantages of using the internet as data, how it allows us to do things that otherwise could not be possible. For instance, to train this model to 120,000 documents, I think. So I think this is kind of a nice example of what we can do when we have a lot of data. On the other hand, I also showed you how online language has its specificities and how we have to pay attention to its characteristics. For instance, with the Vine example about the differences between online texts and what we used to have in the traditional corpora where we used to have just printed texts. Okay, so thanks for listening and thanks for my collaborators.